All right, guys, let's knock out this review. Number one, graph that, say the domain range and asymptote. First of all, it's got a -2 at the end. Remember, the asymptote for any, this is exponential growth because E is bigger than 1, it's 2.7, so no more than 2.7. The -2 at the end shifts the asymptote down to 2. And we're always going to go 1 above the asymptote for my first point. Actually, there's a +3 there, so I'm going to take that point and go left 3. So let's go left 3 because of the +3. Then my second point, I'm going to go 1 to the right of the first point. I'm going to go up by 2.7. So I'm going to rise up 2.7, about right there. Then to draw my graph, I'm just going to connect the dots, just like that. Now, tell the stuff over here. My domain, all real numbers as it goes left. I'm having a hard time. I'm sorry. Left, right, forever. The range, it goes from -2 up forever. And then the asymptote, don't forget y equals -2. And there's number one. Number two, population of a certain species of bird is limited by a type of habitat required for nesting. Population behaves in this way. This is exponential. So this is logistic growth. And it says what happens at time 0. So I'm going to put 0 in for the t right there. And if I put 0 in for that t, the whole exponent becomes 1. I'm sorry, 0, which means the e becomes a 1. So my denominator is really 27.5 plus 0.5. So I'm going to get this right here. I'm getting 5,600 over 28 when I plug in the 0. Just punch it in your calculator if you even need to. And obviously you're going to get 200. So the original at time 0, there were 200 birds. All right, then it says, how about 3 years? So with the 3 years, I'm actually going to take the 3 and plug it in for that exponent right there. So I'm going to take a second and punch that in and see what I get. And make sure you can punch in and get the same thing. I'm getting 227.6, but because it's birds, we just go with 227. I'm not going to round up the birds. So hope you got the same thing there. Number 3, radioactive substance decays in such a way that the amount of mass remaining after 2 days is this. Find the mass at time 0. So at time 0, again, putting 0 in for that t, which makes the whole exponent 0. E to the 0 power is 1. 6 times 1 is 6. Piece of cake there. The second one, I'm going to punch in like this. 6e, my exponent's going to be -0.087 times 20 for days. I'm just going to punch it in, see what we get. When I punch all that in, I'm getting 1.05. What is that in? It's in kilograms. I should have put kilograms after the first one. Kilograms there. Okay. Number 4. If 6,500 is invested at an interest rate of 7.25% compounded continuously, that's the key word. When you see continuously, that means we're doing the PERT formula. Find the value after 12 years. So I'm going to set it this way. The P is principal, how much we start with, which is 6,500. I have E. My exponent is going to be R times T, which is going to be 0.0725 times 12. So I'm going to punch that in. And looks like I'm getting about $15,514.92. You should get the exact same thing. Double check that. All right, number 5. An investment of 8,000 is invested at interest rate of 4%, compounded quarterly. Okay, because it says quarterly, not continuously, we're not using PERT, we're using this one. A equals P, the compound interest formula, which looks just like that. And quarterly is 4 times year. So it's going to look like 8,000 times 1 plus 0.04 over n, which is also 4. And my exponent is going to be 4 times 7, which is 28. So let's punch that, see what we get in there. I'm getting right at $10,570.33. Make sure you're getting about the same thing. Number 6, graph the function. First of all, remember these are inverses of exponents. So the asymptote is usually the y-axis instead of the x-axis. And draw that. My first point is instead of 1 above is 1 to the right. And then what I do is I'm going to use the base down here. The base is 4, so I'm going to go that far. I'm going to plug in 4 right there. 4 log 4 is 1, so I'm going to go over here 4 1. There's my 2 points. Going to graph the graph just like that. That's all there is to it. Number 7, same thing. This one, same graphic, says it's been shifted up too. So the asymptote's still the same. Okay, it's still coming down right through here. My first point's usually 1 to the right, but this time I'm going 1 to the right and up 2 because of that plus 2. Last time I also went 4 1, but I'm going to go up 2 from there, which is right there, and connect the dots. And I'll need to see those 2 points in your graph tomorrow, so make sure and show me those 2. That's 6 and 7. Let's go to number 8. Find the domain of this one, log base 5x minus 5. Now here's the deal. Logs cannot be negative. They actually can't be 0. They've got to be positive. You can't have a 0 there. So all I'm ever going to do is I'm going to take that x minus 5 and set it greater than 0 every single time. So if I move that over, that's my domain right there. I'm going to write it this way. I'm going to put it's got to be bigger than 5. It can't equal 5 because you can't have 0 in there. The next one starts the law of logs. All the bases are the same. When you see subtraction, it means division. If you see multiplication, if you see addition, it's multiplication. So I see these two first. Actually, I see two minus signs. So I guess we could do this first. I'm going to do log base 3, 100 over 18. That's combining the first two, and I still have this. Okay, now watch what I do here. Don't let this confuse you. But remember, when you see subtraction, it means division. So I'm actually dividing this first one divided by 50. Because of the subtraction sign. Now when you divide, this is a long way of going about this, but when you divide, remember you actually change flip, so I'm gonna make that 1 over 50. That goes in 102 times, which gives me log base 3 of 2/18. Guys, that reduces to log base 3 1/9. And you can solve that one. 3 squared is 9, and because it's a fraction, it's been flipped, the answer is gonna be -2. To all that, so be careful there. Pretty good problem, and that's a long version of how to do that, but it does get you all the way through. Number 10, use the laws of logs. These are for me to say. Use the laws of logarithms to expand the expression. Okay, on this one, let's take one at a time. So I'm seeing multiplication. Come on now, I'm seeing multiplication. So I don't know what's happening with my marker here. Sorry about that. Let me fix that a little bit, or a whole lot. Okay, we should be good now. All right, log base 2x. I'm gonna put a 1/2 because there's a, let's just do this. Log base 2 square root of xz. All right, now, I'm gonna split up the square root. First of all, the 1/2 is the exponent because it's a square root. So I have this. That 1/2 goes for the x and the z. So I'm going to break it up as far as I can. It'll be 1/2 log base 2x plus 1/2 log base 2z. Let's go to 11. One thing you could remember, anything that's in the numerator is going to be a positive. So I'm going to say log x plus log y. And anything in the denominator is going to be subtraction. So I'm going to say log minus log 4th root of 2 plus x. And all I want you to do to finish that a little bit is let's do this. Let's take that root out and make it an exponent. Remember, exponents go in the front. 4th root is really 1/4 power log open 2 plus x. That's as far as you can go. Remember, we cannot split up addition. We can split up multiplication and division. That's it. All right, number 12. Now we're going backwards. We're going to combine them. So here we go. First, well, let's do this first. I see a 3 in the front, which is the exponent on the x, which is x cubed. I see a 2 in the front here, which is the exponent on the x squared minus 3. The first two, well, they're all added together. So to finish here, I'm just going to write one big natural log. I'm going to put natural log of 4x cubed, x squared minus 3 squared, boom, 1 log. When they say combine, they mean write it as 1 log if it's even possible to do. And that's all you can do there is all addition, which is all multiplication. Okay, keep going. Sorry about that. Let's go 13. That's a lot going on in 13 here. Okay, the first thing I see is these two are added together. So let's do that first. If I add those, it means you're really multiplying because you can't add logs. If you multiply those are conjugates. You get a squared minus b squared. And also, let's go ahead and take that c, that 2 and make it the exponent on the c. What that leaves me with is 1 minus sign. Remember, you can't subtract logs. Instead, you divide. So I'm going to take the natural log, the numerator, over denominator, and there it is. There's 13. 14, use a change of base formula. So change of base formula means you do log of the big number, 9, over log of 4. And just punch that in and see what kind of decimal we get. I'm getting 1.58, well, really 50, 1.5850. Number, what are we on now? Number 15, express that in exponential form. Remember the finger thing we talked about on Monday. That base to that power equals that. That's what I'm going to write. 8 to the 2/3 equals 4. That's all there is to it. Okay, they just want you to write it as an exponent. Same thing on the next one, so going backwards. I'm writing log. Whatever the base is over here is the base over here, base 81. Remember, the answer to a log is the exponent, which means a 1/2 has to go there, which means a 9 must go there. That's all there is to that one. And the last three, well, these three, I don't think there's the last three, but close. 17, remember the answer to a log is the exponent. So number A is asking you 4 to what power 64? Third. 5 to what power is 5 to the 7th? Are you kidding me? 7. Part C, 5 to what power is 1 over 125? Now, because the 5 became a fraction, I know it's got to be a negative answer because the 5's been flipped. So now the question becomes, what do you raise 5 to get 125? The answer is third power because 5 cubed is 125. The negative flips it. 19, 3 more. Now it's 3 more. 19, sketch the graph of this, label all the asymptotes, intercepts, all the things. So I'm going to factor the numerator, which should be x plus 2, x minus 1. I'm going to factor the denominator, which is x minus 3, x plus 1. And here we go. First of all, let's go x-intercept. X-intercept makes the numerator 0, which is negative 2 and 1. Y-intercept. Look back at the very beginning, cover up the x's. That leaves a 2/3. The vertical. So it makes the bottom 0, which would be x equals 3 and x equals negative 1. And the horizontal, because the degrees, was the degree the same? Yep. And you do leading over leading, which would be y equals 1. Still, my marker's too thick. Okay, here we go. So x-intercept, negative 2 right there, 1 right here. Y-intercept is 2/3, which is about right in there somewhere. Horizontal asymptotes, y equals 1. So here's the horizontal. Have 2 verticals. One's at negative 2. Sorry, vertical's at negative 1. I think I said negative 2. Negative 1. And also x is 3, which is right here. All right, this is a matter of seeing how the graph goes. The graph, you punch it in your calculator. I know this side over here is doing this. I don't know if I go to the far right and I plug in 4. Let's see, that's positive. That's, yeah, it's going to be up here. And the middle section, to be honest, I don't have my graphing calculator with me, but I'm almost positive it's doing this kind of thing right there. You can double check me on that. You can just punch that in your calculator. And if I were going to punch in my calculator, I'd punch in, sorry about that, I'd punch in the original, not the factored part. Just too much to punch in there. Okay, number 19, use synthetic substitution. You got to show me synthetic substitution. If they tell you p of negative 2, put negative 2 in the box. Watch out for zeros. There's not any zeros here. Let's go through here. 2 goes, bring the 2 down. Negative 2 times 2 is negative 4. Add them up. Multiply, add them up. Multiply, add them up. Now remember, it's called the remainder theorem because the answer is the remainder. Make sure you write your answer this way. P of negative 2 is negative 7. And there you go. Just got to do the division, find the remainder. That's all there is to it. Now, 20. It's going to look like this tomorrow. Okay, big number on top. The hardest thing, like everybody that's listening to this video knows right now, if they see a sign in a power 4, you know it's going to be a square root 2 over 2. What you don't know is it positive or negative, so you got to figure out the quadrant. All you do is this. How many times is 4 going to 33? The answer goes 8. What's the remainder? 1/4. So that's what I'm really doing, 8 and 1/4 pi. So here it goes. Remember, that's 0. That's 1 pi. That's 2 pi. So if I'm going to go to 8 and 1/4, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. There's 8. If I go 1/4 of another one, it puts me about right there, which is in quadrant 1. So that's it. Quadrant 1, everything's positive. Tomorrow will be a big number like that. I'll be honest, it's not as big as 33, but just do the division, make it a mixed number. Should be good to go. All right, so hope that helps. See you tomorrow when you come in to make 100. See ya.